you can search for Microsoft Azure Singapore group. So you can, before hand over to Maxim, there are a few reminders. Please keep yourself on mute. If you have any questions, you can raise your raise hand feature or you can put in the chat box. This session is being recorded. If you like it, please spread the words in social media, Facebook. Yeah, I think the stage is yours, Maxim.
Yes, thank you very much, Mohammed Asif, for the introduction and for inviting me to speak for the amazing community you run, you organize in Singapore. It's my great pleasure to present for you folks. Yeah, let's just start. Let me share my screen. This one.
Yeah, we can see.
My today's session is about Azure Cloud for the web front-end developers. So this will be especially interesting for those who build web front-end experience, but maybe even broader for developers in general, because it's always nice to stay updated with what's happening in the cloud, what kind of new services are there. And if we remember the mission of Microsoft, the general one, is it's to empower every person and every organization on the planet to achieve more. And this is very well matching with what Azure brings to web front-end development. It definitely empowers web front-end developers to achieve more, maybe with less efforts. Quickly about myself. I do developer engagement in Microsoft Norway, and let's stay connected on Twitter, webmaxru. I mainly post about cloud, about web front-end technologies, about progressive web applications, so all cool new things that are happening there. And I myself do web development in various forms from actually end of last century. So before joining Microsoft, I spent 20 plus years in that area, and you'll often find me on the stage of technical conferences, in-person ones like before COVID, or remote ones like now. Hopefully sooner or later it becomes possible to travel again. It's my pleasure to visit Singapore with in-person session about some cool new things related to Azure. And yeah, I do lots of the technical speaking and blogging, and I'm personally big fan of developer communities like you are members of, and I organize multiple communities here in Norway where I live, plus a few conferences. This is one side of my personality, and this is another side of my personality. I'm not sure it's a dark one, but it's definitely different. I'm also hobby music producer and hobby DJ. You can ask me, why do you ever present about that kind of your hobbies, Maxim? I will answer you, because this is very related to the next pieces of information I'm going to share with you. So, as a hobby DJ, I always felt lack of a particular tool for building my creative DJ sets. It's something that can count beats per minute, or BPM. This is very useful information if you want to mix two tracks together, especially if one of these tracks you play or produce live and you don't have any like digital counter like on DJ players. So you really want to get the tempo, some at least rough understanding of the tempo from the music you hear. So I built this tool myself because I couldn't find anything stable, free, and nicely working. I used what I have expertise in: web development, web front-end development to be precise, so JavaScript. This tool is working in the browsers. and you don't have to like install it, and it's purely front-end client-side driven application. It doesn't send audio stream to any server. So this is really showing the power of current web APIs. You literally can analyze audio in your JavaScript and do some filtering and do some calculations. And yeah, it's a pure static web application, index HTML, some CSS, some JavaScript, nothing more than that in its simplest form. And I'm a big fan of progressive web apps, so I made it installable, I made it offline ready, so it acts like an application if you wish. So it's actually a form of website, but if you wish, you can install it on your machine and it will work without any internet connection. I was so inspired by this tool, by how it's convenient and simplifies my life. I even gave name to this tool. I call this BPM Techno, and going a bit in advance, I registered a hostname domain for this, and I asked myself, what's next? Now I have this tool available for myself. So it's running on my local host. I do it for my from house streaming of DJ sets. And I definitely want to share this tool with the global DJ and music producers community. How can I make this way from local host port 3000 to globally distributed application? And then I have a short, simple roadmap of the features I would like to add. Maybe in the future, I want to add user authentication. For example, people can track history of their favorite tempos. So maybe some of them will be surprised, or I'm actually such a big fan of quite fast music, or no, I love slow tempo. Yeah, just simple stats, but you have to be authenticated for having this, of course. At the same time, I really want to focus on what I can do and what I can do on a very good technical level, and this is front-end development. So this is JavaScript and everything around. Then I decided for myself, well, definitely I need help of the cloud providers to implement all these current plans from what's next chapter. But what kind of features, what kind of services, what kind of advantages do I expect from cloud provider for my particular project? And I believe these wishes, these requirements are not anything exotic, and very many individual front-end developers and front-end developer teams from small companies, medium companies, from huge companies, they want to solve exactly the same issues. So let's list what I appointed for myself, what I want to get from the cloud provider. If we talk about hosting itself, no questions, no doubts. It should be fastest on the market, and it should be reliable. It should be like always on, always online, right? Then I mentioned that the community of DJs and music producers is really global, and it makes total sense for me to host my application not on one single server, for example, in Norway or even in US. No, I need to have a globally distributed set of servers hosting my application, just to be as close as possible to the consumers of these servers. Next. Modern front applications are a bit more complex than index HTML saying hello world. Many of them, majority of them maybe. And it's not a secret that quite a few of modern web applications are single page apps like SPAs, and I see rise of server-side rendering technology. So the servers of this cloud provider should be able to support all these features, because it's something that required from web server setup some extra efforts, right? Then I already mentioned that I registered custom domain for this application, so supporting of custom domains instead of some random names is a must-have. Plus, everything is under HTTPS these days. I personally do not trust websites that use HTTP. Yeah, I'm just stopping using them completely. So I want this SSL certificate for my project, and I want this for free. Next, if we talk about deployment, this exact way from something, from the code I have on my local machine where I develop this application to, again, globally distributed set of websites, right? How do we do this way? Well, as a web front-end developer myself, I don't want to know too much details about that, at least now, right? Maybe later I will learn a lot of interesting things about operations and about DevOps, but now I really want to focus myself on development of my project, of my code, and I want to have this full automation of all next steps. Then, if we talk about staging environments, I have some features in mind which I want to add to my application, and I'm not sure that these features are good ideas. First, something new that I add might be unstable, and second, I maybe want to gather some feedback from my peers if they think that this change is good, or I just have to drop this. So I really want to have some extra environments also publicly available, but not part of my main address of my main branch. And I also want to have them kind of for free in terms of effort from my side. I don't want to set them up, this the host names and the new deployment flows. No, I don't want to spend my time on this. So in the big picture, I don't want to gain DevOps skills right here, right now. Again, maybe later I will have time to explore this, but now I'm a front-end developer. And next set of requirements. As I mentioned, I have some roadmap of features planned, and why not to get help from the cloud provider in implementing all these features? Now we talk about static web application, but what if I want to add just a couple of simple API endpoints, maybe to gather feedback from people, was BPM detected correctly or not? Simple API endpoints to gather some statistics in the database, and that would be cool to get some help, some support from cloud side on implementing of this. Then, if we talk about authentication, authorization, well, I can implement these flows myself. And also, actually, it involves some parts of backend development and maybe even database administration, right? If you want to store your users' information about their accounts, logins, passwords, etc. But maybe this is not something I want to be focused on right now. And if there are some helpers from the cloud vendor side, I will appreciate that kind of help. Maybe I can even organize some kind of role-based access control. I'm as admin can do these kind of tasks. Folks as users, they can only access their information. Well, it will take some time for you to implement everything from scratch, so helpers are highly appreciated. And last but not least from this list, I definitely want to develop everything on my machine locally. And if you talk about pure static part of the website, it's not a problem, right? You spin up any static web server and you build your application there. Is it React or Angular or whatever? But when we start reasoning about APIs or about authentication, authorization. Well, it's not that simple to reproduce this, let's say, cloud environment on your local machine. And if there is a tool to simplify this implementation, this will be also really cool. And as a foundation of all these requirements from my side, I have this one. After all, this is my personal hobby project. I do not plan to somehow monetize this. And from my side, I don't want to invest any dollars in hosting of this project. I invest my free time, my spare time into this, but not money. So I want to have a nice free tier to host this application for at least start with sharing this with the global community. Maybe then later, if it becomes super popular with a million visits per day, this free tier will not be enough, but this is somewhere in the future and might happen or not, right? We are talking about here and now. I don't want to spend any money. And you know what? There is a service like that from one cloud provider we all know. It's from Microsoft Azure, and the service name is Static Web Apps. And to be honest, I took some small part I'm proud of in implementing of this service together with Azure engineering team. I provided my feedback on how to build proper configuration and some architectural decisions. So yes, this is officially my favorite service we have on Azure these days. Well, so I started with this service. I successfully built and deployed project, and I will definitely demonstrate it in our session. How can you start with building new project or moving your existing project, web frontend project to be precise, to Azure Static Web Apps? There are two main ways for you to start. And the flow itself is very similar in both cases. Yeah, I will explain these steps in a few seconds. So the simplest way is to install an extension for VS Code editor. Yeah, for those who use VS Code, I see that it's very popular among developers. So maybe majority of you actually have this code editor as your main code editor, and you know that there is amazing ecosystem of extensions. And Azure Static Web App has its own extension, so this will be super simple for you to start. Literally, you open folder with your web frontend project, React, Angular, Vue, Svelte, your favorite framework, your custom framework, no framework at all, and yeah, you just click plus button like you see on this screenshot. Or you can go to Azure Portal and search for Static Web App service and click create button. In both cases, what's needed from your side? First, it's all about some existing code repository. Again, this is not any kind of exotic requirement, right? We host our source code in this or that service of code repositories, so it's definitely exists somewhere. So you just point to this code repo, you provide a few options of the configuration for Azure Static Web Apps to know about your application structure, like where the application is located in your code repo. Is it like root folder or maybe some subfolder if you use a monorepo approach? Then you provide folder where you have your build artifacts, and this folder is different for different frameworks, and you definitely know as a web frontend developer where you actually have the files ready for being deployed, and a few more options. Then you count 3, 2, 1, or maybe a bit longer if you have quite sophisticated build flow, and magically your application is online, and you even receive your test URL, like two random words dot Azure Static Apps.net, something like this. So you can definitely start immediately with testing how your application looking like for everyone else. So it's publicly available, and of course then later you can connect your custom domain here. So it was the flow how to start with Azure Static Web Apps. Okay, now imagine that you have a version of your application hosted globally, geo-distributed. But what will it take from you as a web front-end developer to deploy a new version, right? So we tend to build new versions quite often, maybe a few times per day. And this is really good approach to have really small iterations and often deploys. So what is the way from having new code on your local machine to again being deployed everywhere around the world? Step number 2, you as a developer build your code and push to source code repo, GitHub or your favorite one, and there is actually no step number 2. It's not required. All is done automatically for you. The rest will happen magically. So after your code landed in your source code repo, GitHub actions will take control over building, and then passing build artifacts to Azure, and then in a few seconds or minutes, depending on the complexity of your project, you will see new version deployed and available globally and publicly. Of course, under the hood, there are many things happening. I already started briefly explaining what's happening there. So after you merged your new code to the main branch, it's landed somewhere on, for example, GitHub, and then GitHub starts its flow based on it starts running GitHub action based on the flow which was created for you, was created automatically for you after you connected your source code repository with Azure. So you don't have to create this flow yourself. If needed, you can fine-tune this later, or you can just have it as it was created for you. So this is why after you connected your source code repo with Azure Portal, expect a new file to appear in .github folder, and this will be exactly file with the flow for GitHub actions. So as a result of these actions, if you have proper build script located in package JSON, GitHub actions will actually receive the build artifacts. Again, your application itself, index.html, JavaScript, CSS, everything what's needed for being deployed, all these static resources, and then Azure will take control over the rest of this flow, and will just copy these artifacts to multiple servers worldwide. And so this may be sort of standard flow where you have your source code hosted on GitHub, but it's also possible to set exactly same flow on Azure repos and Azure pipelines. So that's also absolutely possible. Okay, next question. How to develop things locally? I already pointed to a couple of potential challenges on local debugging of, for example, API endpoints or authentication. We have awesome helper here also called Azure Static Web Apps CLI, or Command Line Interface. It's a package on npmjs.com which allows us to actually get these helpers in development and debugging APIs and authentication. So it contains all needed runtimes and mocks for you to at least mimic all these authentication flows. And you actually run pretty much full-scale Azure Functions runtime on your machine if you wish to build some API endpoints, if you wish to add some API endpoints to your web frontend application. So how to start with CLI? Well, it's classic. You install this package. I strongly recommend you to install this globally. This is why you have this -g, and then you will have SWA command available on your terminal, where you provide some parameters. Again, some information about your application. For example, this command you see on the bottom of the slide is full scale dev environment for let's say a generic React application. A React application created by CRA, Create React App Library. So by running this command, you will run static web server, you will run functions runtime, you will run all mocks needed for authentication. So literally, this will mimic environment you have on the cloud, but locally on your machine. Awesome. What's next? Next, it's demo time. Let me show you folks what kind of project I built, and yeah, maybe we can even test this in action. So I will demo how it detects BPM, bits per minute. Let me stop presenting this. Let me close the slides for a few minutes, and we'll return to them. The application itself here, and by the way, please feel free to test it yourself to use it after all. If you maybe use some, if you do some DJing or music production, the host name is bpmtech.no, so it's in Norwegian domain zone, and it works very well for the name. You see, it's like techno. I'm super proud of this domain name I invented for myself. Yeah, and to demonstrate, I even created a simple track. I recorded it myself. So let's try this in action. I hope that noise cancellation will not cut music off, and I hope that you will hear this. To start listening, we just click that button, and you see the spectrum analyzer started to work. Now it's it tries to analyze BPM of my voice, and there is no sense in doing this. But if I, for example, clap, you will see. Yeah, so visually that works. And now let's try it on some real music. Super quiet. Yeah, so after some stabilization, it pointed 120 BPM, and it's correct one. This is the tempo I created this music sample with. So we can, for example, say, yes, it worked correctly. And by providing that feedback, we actually trigger an API endpoint. I also implemented using Azure Static Web Apps. It's part of services we have for building this API endpoints. So let me show you on the network. Maybe let me zoom that in. If I click that button, the call to API/feedback is going out, and then Azure function takes control over the data it receives, and then it stores this result to Cosmos DB. Good. So this is application itself. Let's have a brief look on how that works. And of course, by the end of the session, I will share all the links to the documentation and to this GitHub repo. So please explore this, please fork it, use it, break it, do whatever you want. This is open source. Furthermore, in README of this repo, I described majority of Azure Static Web App's functions, or at least the ones I actively use as this project. So maybe to save some time, today we will not go through all the possibilities I implemented in this application, but you can always refer to this repo and to this guide if you wish to implement some features yourself, or maybe I will inspire you to run similar presentation for your team, for your friends, for your community. After all, please feel free to use this project as a sample. Okay, let me show you a couple of things, at least a couple of things, and we will start from the build flow. Let me open code editor. This is BPM counter project. What I want to show here is package JSON, where you see that I have build command as a part of scripts, and actually this is what happens when GitHub Actions try to build my application before deployment. So this is very important for you to have proper build command in your package JSON. By default, it's npm run build, but if you have something very custom in your project, you can always change this default command, where to change all the parameters. In the file which will be created automatically for you right after you scaffold your static web apps resource on Azure Portal. This is the file I mentioned, which will appear automatically on your repo in .github/workflows folder. And actually, this is GitHub workflow, which explains GitHub Actions feature what to do. As I mentioned earlier, there is no reason for you to understand in details what's going on here. This is basically just explanation to GitHub Actions what to do and when. So you see something will happen on push and on pull request, and this set of actions will happen. Here you can customize some things or change configuration. For example, if you changed build artifacts location from build to something else, but for majority of React projects, this is just build folder. At the same file, you can provide your custom build command if needed. Okay, so I already told you that if I do any change in my application, for example, I don't know, if you open index.html and change something here, and then I will push it to the repo. In a few moments, okay, maybe a minute or two, the new version will appear globally. But as this project is currently in production, I don't want to add some test features or some random changes. We can look on another feature, staging environments. Maybe this is also super useful, and you see that this action will run on push and on pull request. So just imagine the situation. You changed some things in your application and you want to test it before rolling out to production URL. Or maybe you can you just want to run some end-to-end tests or integration tests on deployment location, not locally. So what you do as a web front-end developer, you create a new branch, you work in this branch, you add all like experimental, let's call it like this stuff there, and you push this branch to your source code repo, and then the rest will be taken care of for you by static web apps. And I have ready to go sample, ready to show sample for you to demonstrate this. Let me open this. So you see, I have one pull request open. I called this new feature. So I decided to change background. Like, what will happen if I experiment with background? Instead of blue, maybe something almost black. What I've done, I created a new branch and pushed it to the repo, and then you see that Azure Static Web Apps created new environment for me, new address, and we can open this and check. Yeah, the black background. I'm not sure that I want to have that new feature in production, but I will decide it later. Now I just have it, and this new address and this new flow was created completely automatically, completely under the hood. So the only thing I've done is created new branch and pushed it to the repo. Also, we can, so how to make this, just a second. We can open Azure Portal and see what's going on there. This is overview of my static web application, BPM counter. Let me also increase the size. So this is initial address I received immediately after I created the resource, and then in custom domains you see that I attached my own ones, and that's completely for free, because I know that some services they charge right after you want to have your custom name here. And also what we are checking right now is environments, or staging environments to be precise. So you see, this one is dedicated to the new feature I created, and this is actually its address. So if I click here, I will open this BPM counter with black background. And if I decide that this experiment is okay, what do? I normally, again, as a web frontend developer, I just normally merge this pull request to main branch, and it's there. And what will happen with Azure Static Web Apps? Well, the same. This will just change. This will just swap this staging environment with main one. I mean, this new feature will the code we have here will reside on main branch, and this staging environment will be deleted for you automatically. If I decide to drop this feature, I just close this pull request, I forget about this, and maybe I also can delete it here. But I will not do this because I will keep it for my next presentations on the same topic. What else? Maybe yes. Let's dedicate next maybe 5 minutes for API endpoints exploration. So here you see a section called Functions. And in a few seconds, now it's loading, you see there is one API endpoint called feedback. And maybe you remember when I detected BPM from my demo sample, I clicked this thumbs up button, and HTTP call to /API/feedback went to Azure. So how does it look code-wise? Well, I'm a web front-end developer. JavaScript is my main language, so that's not a secret that I decided to go for Node.js to write backend side code, and I created Azure Function using JavaScript and Node.js as environment. So this is my function. If I want to add more API endpoints, I can, for example, use the same VS Code extension to build more. And maybe let me demonstrate how that looks. So this is on that subscription. This is BPM counter, my project. No, I don't want to update right now. And you see these are environments listed, one production and the new feature, which I just demonstrated. And here I can create new HTTP function. Let's keep it default name, HTTP trigger, and it's even created sample code for me. So if you go to the list of the files, yeah, this is our second API endpoint. I built some JavaScript code here, and then I push it to my source code repository, and it automatically appears in production as API/HTTP trigger one endpoint. As simple as that. And of course, you definitely don't want to keep your secrets in and passwords in GitHub. This is why, for example, when it comes to the connection with database, here I just use another feature of Azure called configuration. So now, so here you see it's loading all my secret values, like username, password for connection with database account. So it's very convenient to push your code to source code repository without exposing any kind of private information. Yes, so let's wrap up the demo, because I have a couple more slides to share with you. Just a reminder that on this GitHub repo, and I will give a link, you will find a more complete demo with more steps which you can use for you to learn or to maybe demonstrate Azure Static Web Apps to someone else. Okay, let me start slides again, and from current slide. Yes, the last how-to left for us is how to continue learning about static web apps. So what I presented in this 35 minutes is, well, maybe it's even enough for you to start, but definitely we, for example, didn't touch such cool things like helpers in authentication. Well, we have amazing resource called Microsoft Learn, and this is short link for you to start this journey. It's fully dedicated. This section is fully dedicated to Azure Static Web Apps, and right after my session, I will repost these links to our chat window, or maybe Asif could help me with doing this. Then definitely we have full documentation on everything, and if learning is more like guides from zero to hero, then docs is a classical explanation of every service, every method, like more structured. And of course, the demo itself. This is actually short link for GitHub repo with BPM counter. Please feel free to explore this. And let's stay connected. I'm here to answer your questions on Azure Static Web Apps, Azure in general, web front-end development, progressive web apps. Yeah, I hope that I can help you with multiple questions and multiple challenges, please add me on Twitter. Let's stay connected there, and on LinkedIn. I will be happy to approve all connection requests from your community, folks. And yeah, that's pretty much it from my side.
Thank you, Maxim. I think it was a really cool demo and session. And yeah, I really like your BPM demo. Maybe I will try after this session. Yeah, it was really nice. There is one question here. Is it possible to simulate multi-factor authentication apps with the CLI?
Multi-factor. Well, actually, what kind of helpers do we have related to authentication? These are helpers based on third-party identification providers. So this is not where you enter your credentials for the application itself. No, actually, you authenticate people using GitHub, using Twitter, using Azure Active Directory, and if I remember correctly, Facebook and Google are in kind of beta mode. So to answer your questions, if you have two-factor or multi-factor authorization attached to these identity providers, yes, the flow will be exactly like you have there. So this part, the authentication part itself, is outsourced to the providers. So you as a developer receive either user email or user handle, and then you build your own application logic based on information you receive. So yes, technically it's supported.
Yeah. All right, thanks. You guys, if you have any question, you can unmute and ask, or either you can put in the chat box. Hi, Maxim. I have one question here. Do you recommend any tool or any means like Azure native tools for performance of the application website from the web front-end point of view, means like loading the website or maybe the performance, so or anything on that?
Do you mean web performance itself, right? Not
yeah, to
performance
check,
of
to test, or means like your
yeah, I really I recommend to read about Core Web Vitals. This is a set of very important metrics about performance. So there are a few articles from folks from Google who actually, from dozens of, if not hundreds of metrics you can measure, you can optimize in your web front-end applications. They literally found like 3 or 5, I don't remember correctly, which really affect user experience, like user perception, because there are actually performance of your application and perceived performance of your application are two a bit different things, and to some extent your application could be slower, but users will see this like a super fast one. It's a bit human psychology and some tricks on that. So Core Web Vitals is something that you want to measure, and there are lots of libraries built around this. So if I remember correctly, now if you scaffold up with Create React App utility, there is like ready to go method for you, even enabled by default to measure these metrics. So, and everything you can measure, that means you can optimize this. Yes, that's my answer.
Well, nice. Yeah, I think yeah, it was really good to see like how in the static web apps, even though I haven't tried before, how the static apps handle the API request and multi authentication. Yeah, it's really great. Is there any limitation for the API API request to handle, or I mean, like will there be any charge for it after some API request or anything on this static web apps service?
That's a good question. Actually, I don't remember exact information about pricing tier. it's definitely not per API call. Maybe somehow related to traffic. I can say for myself, I didn't pay any cent yet. So yes, you can get enough API endpoint calls for free. And if you wish, please go and explore. We have a pricing page on Azure Static Web Apps page. Azure Portal.
Yeah, I think maybe I need to transfer my own blog to this web apps, static web apps in future.
Yes, actually, the limitation is about runtimes you can currently use as API of Azure Static Web App. So definitely Node.js is something that possible to use, and I believe the same with .NET, but I don't remember, for example, if you can use Java or Python or PHP runtimes there. Most likely not, but it's changing so fast, so I don't even have this in my presentation because yeah, I might just give wrong information. So the best option for you to go and check. So in that sense, this is slightly limited compared to let's say classical Azure functions. But you can also connect, of course, your full-scale Azure function account to your application. But what also optimized here, why is that super convenient to use API endpoints as a part of Azure Static Web Application, is the fact you don't have to set up any course headers. It's done automatically for you. You just call /API name of your endpoint and bam, it just works.
Yeah.
This is what I really like.
Really
it
works.
just works.
Yeah. Okay. Thank you very much, Maxim. It was really wonderful session and demo. We really enjoyed it. Hey guys, if you have any further question, you can unmute and ask, or you can follow Maxim on Twitter. He's quite active, so you can ask directly to him. And I think he have given a demo link. I have also given the demo link and docs links in the chat box. So please try. If you have any further question, you can just ask to him, or you can raise the issue on the GitHub, or pull request, whatever you want. Just do it. So thank you again, Maxim. We really enjoyed, and we are really honored and happy to host you. And maybe in next time future in Singapore, we personally, we physically host you. Thank you.
I love this plan.
Yeah. Hey guys, we have, yeah.
Thanks, folks, and good luck with the event. I have to jump off, unfortunately. I have more calls scheduled, and yeah, I really enjoyed to present for your community. Thanks for your awesome questions, and yeah, good luck with the next events. I'll keep following you. Bye.
Thank you. Hey, I think Jonah, you're there. We have another speaker there.
Yeah. I'm
yeah.
here.
Hey, how are you?
I'm great. Thank you for your session, Maxim. I like the BPM app. I'll try it.
Nice to meet you, Jonah.
Thank you.
We all enjoyed actually.
Yes.
Yeah. Guys,
Bye-bye.
so thank you, Maxim. Here we have another wonderful speaker from Women in Tech from Sweden, Jonah. She's a Filipina Swedish Microsoft developer. She is a Microsoft MVP, and she runs one of the wonderful group of in Azure group in Sweden. And yeah, she's going to talk on Azure Durable Functions today, which is a part of extension of Azure Functions. And this talk is going to be really interesting. So I would not take much time of you.
Yes,
so how are you?
Thank you for. I'm great. I'm actually working today, but it's good to skip 1 hour from work to share knowledge about one of the technologies that I'm passionate about. Yeah, so thank you for having me, and I hope that you learned something from this session. It was a great session of Maxim. He talked about Azure Functions as well. So let me just share my screen. Let's see. Can you see my screen?
Yeah, we can see.
That's good. All right. So Hi everyone. I'm in Sweden right now, and I hope that you're having a good evening or evening there. It's 2 p.m. in the afternoon here in Sweden. So today I will be talking about fundamentals. So it's not an expert or advanced level, but it's like the basic things that you need to know about getting started with durable functions in Microsoft Azure. So I'll introduce a bit about serverless. I'm sure all of you are familiar with serverless and cloud computing, but I thought I'd do a bit of introduction to that. What are Azure functions, durable functions, the different patterns, because durable functions help in solving complex problems, and some demo examples and learning resources. So I know that I was already introduced, but I want to share that a bit about me. So I'm a software developer. I code fullstack.net. I'm also passionate about developing with Azure. I'm MVP and recently a Microsoft certified trainer. And I also founded Azure User Group Sweden, which I think in February, because I saw that that community was missing in my city here in Sweden. So I started it, and I organized bi-weekly events with another MVP, which is located in Norway, where Maxim is located as well. And I'm currently writing a book about Azure with O'Reilly. So I'm a first-time author, so I'm working on that in weekends. And I also mentor some women in tech to get started coding, because programming is not hard, and it's not about gender, but it's about solving problems. So I want to start my session about this image, because I know that most of us have been locked down because of Corona or COVID. We miss traveling. I myself like traveling from new places to another. And I'm originally from the Philippines, which means I'm neighbor to Singapore. And I've also been to the airport in Singapore. Singapore has one of the best airports I've been into. And I want to show you this one, because I'm sure that when the restrictions are over, we're going to be there will be lots of airport queue. And that will also cause problems, because even though we have self-service kiosks, there's definitely a queue, like the physical line. And my point here is that sometimes we don't want to stay in there in the queue. We want to be able to do something else, like relax in a spa somewhere in the airport, or go to Starbucks and get grab a cup of coffee that we like, instead of standing there and being afraid to not lose our line. Somebody else might grab it. But in programming as well, we experience problems. Like, for example, when I was studying Java, I studied Java as well. I had my teacher shared about this the dining philosophers problem. Probably many of you have heard it as well, but it's about the scenario where there are 5 philosophers in the table, and they only have 5 forks. And one philosopher must need the forks from left to right in order to eat. Otherwise, he can't. So just like in programming, I mean, just like this problem, in programming, there will be common issues like a deadlock, which means that if one of the philosopher picks both of the forks, that means all of them won't be able to eat. And then when they're not able to eat, there will be starvation. So it's the same thing also with a problem in programming. Sometimes I myself have do both development and bug hunting, debugging bugs. And for me, one of the in old systems, for example, it's hard to debug or find problems with concurrency, like racing conditions and deadlock. Sometimes it's hard to debug them or to find solutions. So that's why I think that serverless solutions like Azure Function is one of the solutions for such kind of programming problems. So as a developer, I love serverless and I advocate about it. I'm talking about it because I can solve complex problems, and I have the opportunity to learn and build modern apps. And it also makes me productive as a developer because I don't need to think about the infrastructures behind my function app. I can just focus on coding and building something. So that's why I love it. And before we dig deeper into Azure Durable Functions, I want to share about Azure Functions. So Azure Functions is also a compute service that many of you probably have tried to develop as well in your apps. It is on demand, you pay as you go, and it's event-driven, function as a service, we call it in that model. And you write less code, and as a developer, you get more productive. So basically, you can also integrate it with other APIs, just like Maxime has in his static web apps with adding API to build his BPM app that I'm going to try myself as well. So basically, Azure Functions is a code, backend code, and then it's events and data. So events are those that are, for example, trigger events like HTTP trigger, blob trigger, and the data which can be output, input that you want to in and then out. So it's code, events, and data, and that's Azure Functions. So what are durable functions? So durable functions, it's the extension of Azure Functions. So they are not they're not in competition with each other, but they are like they complement each other. So it's the extension of the Azure Functions. The only difference is that durable functions allow us to write stateful workflows in serverless environments. And it's also an Azure Compute Service, which means that it has the same features as Azure Functions, like you can pay as you go consumption, and it's also container. It's also built in a function app, just like Azure Functions. And the good thing about durable functions, unlike Azure, the normal functions, is that it manages, it checkpoints and restarts the state for you. And the technology behind it is the durable task framework, which you can see in this GitHub repo. And there are some common languages supported, like C#, JavaScript, Python, F#, and PowerShell. And since I'm a .NET developer and also kind of full stack sometimes, I code it with both C# and JavaScript, but I'm also learning to try how to do it with PowerShell someday. So when you use durable functions, there are different types of it that you need to be aware of. There are actually 4 types. So the first one is the client function, and the client functions are like starter functions that are used to trigger the stateful orchestration. So client functions can be an HTTP trigger, a blob trigger, or a Cosmos DB trigger. And what it does is that's the starting point, since it's event-driven, so it kickstarts your orchestrator functions. And your orchestrator function, that's where it's like, that's your orchestrator, as the word it says. That's where you write your workflow on how you want your tasks or actions to be done. And this is where you design what needs to be done or when it stops and everything. So, and then the orchestrator assigns and calls in the activity functions. Activity functions are like normal Azure functions, where you can code in all your logic there, and you can do things like, for example, send an email, send an SMS, or save this file to a Cosmos DB database. So those are like small tasks that the orchestrator asks to do. And then the next one is that's the one. And then the next one, there's also something called entity functions. So entity functions, they're a special type that are used for CRUD operations for durable entities. And the special thing about this type is that it needs to use entity trigger instead of the normal client function trigger. And then it's only supported in right now, as of the time I wrote this. Maybe it's supported more right now, but it supports .NET and JavaScript, and it's supported in versions 2.0 and above. So, what are Azure Functions? So Azure Functions are stateless, and durable functions are stateful. So stateful workflows, then it's recommended to use durable functions. And Orchestrator of all types plays an important role in developing durable functions. It's because it needs to be deterministic. Why is that? It's because the workflow, they will be replayed. So, for example, once your app is running and you have an orchestrator, it waits. It's long running. So if you put a lot of like undeterministic code in your workflow, it might cause runtime errors. So the technology behind this orchestrator function is in deterministic API. So there's a documentation about it, about why it has to be so. And part of that documentation is actually, before I do deeper to the constraint, here we see an example, deterministic versus non-deterministic. So with deterministic orchestrator, as you can see on the left side, we have an orchestrator which calls in different types of tasks or activity functions. So it's organized, it's planned. But if you don't have an orchestrator, it looks like this, like it's just everywhere. It's isolated, just like when you create a function app or one function. So they're kind of like mini functions or microservices that perform specific tasks. But the difference of this is that when you don't have an orchestrator, or if it's not durable, when the VM, the virtual machine of that one of the function app here, for example, gets restarted in Azure, for example, data center needs to be restarted, and maybe we're not sure when it happens, so they can lose its state. So with durable functions and an orchestrator, it's good to have. So now to the constraints. So in the constraints, there are some do's, don'ts, and do's when you code your workflow. For example, since it's deterministic, it is not recommended to write GUIDs or random numbers in your workflow or orchestrator, and also putting in configurations like database connection strings in there, as well as blocking APIs and infinite loops and date time, because date and time, it's not stable. It changes all the time. And what's recommended instead is this, line per line. So you can use new GUID. And if you need to have configuration, you can have it in your activity function. And if you really need to use like to do some wait or sleep, you can use the durable orchestration context, which has specific methods for those types. And if you really need to have a loop in the workflow, then you can use create as new. And for the date time, there's a specific method for that in the context. So I hope there's no questions so far, but I can take the questions later on. Yeah, so So we proceed to the different patterns of durable functions. So there are actually 6 known application patterns that durable functions can help solve us in our complex problems. So the first one is what we call function chaining. So in function chaining, you execute a sequence of functions in a particular order, just like a chain. So as you can see here, you have function 1 passed in the output to function 2 and function 3 to function 4. So the output to function 1 is required to the next function. So this is function chaining, and this is useful if you have a chain of actions that you want to do that requires to be stateful. And in my demo later, I have an example of a function chaining. So I will show you some demo or example code for that. And in action, function chaining looks like this. So for example, you have an HTTP trigger or a blob trigger. So when that function or client function is triggered, the orchestrator is started, or the orchestration is started. So the activity 1 is scheduled. When the activity 1 is doing its job, then the orchestrator sleeps. And then when activity 1 is done, the orchestrator wakes up, and activity 2, the next activity is scheduled. The orchestrator sleeps again. Activity 2 is done, and then orchestration, the first orchestration is completed. And that's the first orchestration. So your entire workflow is long running, which means that if you upload another blob in your Azure storage or trigger it again with HTTP trigger, then it goes through the same process again. So this shows the overall that it's important that it's deterministic because it's replayed. And in this workflow as well, I mean in the durable orchestration, the good thing about orchestrator sleeping is that it's not just that it will be healthy, but it's also good for us developers or organizations, because when the orchestrator sleeps, you don't really get charged for those activities that are not scheduled by the orchestrator. So if it's only activity 1 that's running, then you only pay for the instance of that activity that's currently working. So that's a good thing of function chaining or durable functions. So here is a simple example that I got from the documentation, C#1. So this is just like a chaining that says hello to different cities, Tokyo, Seattle, and London, and it returns an output of strings. So it's a pretty simple code example. And the next pattern, the second one, is called fan out and fan in. So this is also very good pattern to use to solve some problems. For example, this is useful, for example, if you want to execute multiple functions or tasks in parallel, and you want to aggregate or combine the results of all tasks as one when they are done. And usually in the code, C# example again, since I'm a .NET developer. So as you can see here, you have an example that you want to back up a site content. So you have your root directory, a list of files, and you want to back up your files by calling a method getFileList. And then you go through the loop of the files, and then in each you have your own task to copy each file to an Azure blob. And then it uses at the end, it uses an await task when all to aggregate the result. That's the in of the fan out, fan in. So that's a simple example of that, and this is useful in some use case scenario. And then the third pattern is Async HTTP API pattern, which is useful if you want to have long-running operations with external clients. And in my simple example here, I have like function, a simple one, to check if my website is available. This is like a long-running one. So I have my context or orchestration in a try-catch, and what I have is I make an HTTP GET request to a specified URL or an endpoint. For my mini example, I have my website, jonahanderson.tech, and I want to have GET method, pass in the URL, and I have a durable HTTP response object. In which I could work on to get the status, so if it's 500 or 600, not 600. Otherwise, I will print in or log, process further the content of that response of my website. So this is, you can use this as well in other endpoints or APIs. And the third one is the monitor pattern. So in monitor pattern, as the word itself, it is useful for a flexible recurring process in a workflow, just like this, another example. So we have a monitor job status in which you have a while loop that checks on the expiration time, and you have a condition to check if the status or the job is completed. And when it's completed, what you can do is you can send an alert, call an activity for that. Otherwise, it's gonna wait, it's gonna sleep, the orchestration sleep until that timer that you set. So this is good for monitoring scenarios as well, that's long running. And then the next one is human interaction. So sometimes we have to create applications that requires human interaction, like for example, approval requests or approval workflows. So for example, you want someone to approve a request, and that escalation person might be on vacation somewhere in Spain or in a tropical land, but sometimes that person maybe don't have access to an email. So it's good in this type of pattern. For example, you can combine it with an external event of both a human interaction, a human that actually do something to trigger it, or you can also set a timer along with it. So if that person respond to your request, then you call another activity to process the approval. Otherwise, there's a timer that also checks if it's processed or not. If not, then you can do something else, for example, escalate that process. So this is the workflow in code. So there's an app called Approval Workflow, and you have to have, there's like a durable timeout here. So you create a durable timer in here, and you set an if condition that when any of those approval event, either the approval timeout from a person or approval event from a person or a timeout that you set. For example, if that person doesn't reply after 2 days, then escalate it, use the timer. So this is an example of that. And then the last sixth pattern is called Aggregator Pattern, or it's also called stateful entities, which is used for aggregating event data over a period of time into a single addressable entity, which means that this identity or event data, they can be coming from different resources, and they can come in batches or anytime. So the aggregator process them as they come, and they are stateful. So you can search more about durable entities. Here is an example here. So there is like a function context that's counter, which is switch case, add, reset, and get. And another trigger in which you can call in signal entity async and pass in your entity ID, the method, and the amount. So the link, more information about that is on this link. And if you want to do more complex, so there are 6, but if you, there's no, like there are known patterns, but actually you can, as a developer, you can create as many patterns as you want, and you can call it as you want. But I want to share that you can also create as orchestration, sub-orchestration within your orchestrator. So it can be complex. I mean, it can be like a hierarchy or a tree, depending on how you want it. But so sub-orchestration in durable functions are, as far as I know, this is currently supported in .NET, JavaScript, and Python. I don't think in PowerShell is supported yet. But what you have an orchestrator, and in your orchestrator, you can create sub-orchestrator with a set of activities in it. So if there's a requirement in your job or your project that needs this, then you definitely worth checking out how to use it in those languages. So this is how it looks in code. So you have a function called provision new devices, and you have a strings of activity. I mean, so you have a strings of devices in which you call in a method called get device ID, and then you loop through that, and then in each of those devices you want to have a task that provisions a sub-orchestration that provisions your devices, and then it uses the when all method. And for developing, of course, we're developers. We are interested how we can get started. So you can develop Azure Functions in Azure Portal. That's the easy way if you want to just click, click, click. So you can do it there as well. But if you want to be nerdy and want to really get your hands dirty, so you can also use Azure CLI or the Cloud Shell. And there you can also code locally, which I usually do. You can use Visual Studio or Visual VS Code for Azure Functions or durable functions. And in order to develop this locally, you would need to have the latest version of Azure Functions core tools. And it's good to have a Postman or something like a web browser that you can use to check on your HTTP requests. And Azure Storage Explorer, it's also on the portal, but you can actually download it. I have it myself. I'll show you on the demo later. And then supported languages, so you don't have to be like expert of any of the languages. As long as you can do C# or some JavaScript language, you can get started coding serverless with Azure Functions. And just like Maxime also, it's kind of like a good combination of sessions that we have, because with Azure Functions, you can do full stack development along with it with Azure Static Web Apps. Like you can create a Blazor app, a React app, and then add in the API support. Actually, Azure Static Web App supports API, adding API, or you can also bring your own functions, which means if you already have an existing functions that's published in a function app, you can actually bring it on in your static web apps in a separate project. So this is a good powers combined between these Azure services. And then next one is the orchestration details. This is when you, for example, when you want to debug or know what's going on with your orchestration. So there is actually important details that are logged within the framework, durable test framework, when you develop. So for example, there's an orchestration ID that you can work on, and there's also the URL. And there's also URL to raise event, to terminate, or if you want to purge the history or restart your orchestration. And that yourself, you can see it. This one is a screenshot that I had when I was working localhost. And this is connected to your Azure storage, because function app needs to be connected to an Azure storage account. And if you're interested to build Azure Functions in containers, it's actually supported. There's a tool called CADA for AKS, the Kubernetes-based event-driven auto-scaling. So you can use that or check on that if you want to develop functions in containers. And okay, yes, that one doesn't look good. Okay, but so when it comes to coding durable functions, there are good things to know. For example, you can use application insights for monitoring as well, especially in production apps. And when it comes to versioning, what I meant here is conscious versioning, which means that when your Azure functions are already in production, especially durable functions, they're long running. So you don't want to interrupt what's in the production already. So we need to be conscious about versioning our changes to a function or durable orchestration. And what I would recommend is using deployment slots. So if you go to your function app, there's an option actually to set it up in Azure. And also using Azure Storage Explorer, where your logs or instance and orchestration logs for web jobs are logged in everything that's done in it. And for secrets, we don't want to put our connection strings and secrets on our app and then we compromise it when we forget to remove it or add it in our git ignore and publish it on GitHub. So I mean, we don't want to get in trouble, especially if we're working with a company. So it's good to make use of the security tools like Azure Key Vault or use app configuration in your function app. And there's a good article about developing durable functions. This green deployment strategies. So for blue-green deployment strategies, if you search on it, you will be able to see like a study or a blog about it. So it was a good one. So you can check it out. And when it comes to error handling, what you can do is that you can try to call another function activity. And sometimes also, you want, when you have a long-running workflow, you might want to abandon a function call that it's taking too long. So you as a developer can actually control it by setting up a durable timer. And the syntax for durable timer is different depending on the language that you're using in the function. So for example, in .NET, you can actually just go ahead and call the method create timer to create the timer. And I believe in JavaScript, it's also the same. Context.durable function.create timer, I think, in JavaScript. So it's in the docs as well. And if you don't want to manually create or call another function activity, there's actually a ready method called call activity with retry async, which means that it automatically retries your activity if it fails. So this is a good one if you want to write clean code and not too much if conditions. So this is a good one to try. And applications insights and app logging when you're working locally, try catch blocks. And also there's a new technology or new repo feature that they added recently. It's called Durable Functions Monitor. It's for monitoring durable functions. So it's in this link. I'll share it with you as well later after the session, and maybe you can get a copy as well. And this is how it looks: an automatic retry, call activity, retry, async. That's how it looks. You call your flaky function that's probably flaky and not working properly. You want to retry it in case. So you have your retry options, how the interval and the number of attempts. And then here we have another example, not using retry, but in a try-catch block, but use instead call activity async, or you catch it by calling another activity. So that's another example. And next one is like unit testing. So you can unit test just like any other development. You can actually unit test durable functions. So you can use mock or framework or XUnit as well to mark both the sequence, the workflow, and also specific activity in your function app. And deployment, if you're doing it on Visual Studio, you can do it in CLI as well, but in Azure Visual Studio, you have the options, several options to deploy your durable functions or function app. You can have it in Windows, Linux, and you can even have it in a container and have it published in a Docker with the Azure Container Registry. So that's a good thing to know, that you can put it in a container. And just like other applications, you can set up the CI/CD with GitHub Actions, with GitHub workflows. You design your workflow, or you can also generate a pub XML file to deploy it using the publish button or a publish profile. So now it's time for demo. So I just don't just keep talking. So my demo is about is an example, simple example of function chaining, where I have an Azure Blob trigger, which gets triggered when I upload an image to an Azure storage. It kickstarts my orchestration, my workflow, which is a function chaining. So what I do is I pass in my blob image data. I pass it in, or I send a message or save that message in a service bus in a queue message. And when it's done, I want to send an SMS or call using the Twilio API. And then when it's done, I want to also receive an email that there's an image uploaded to my Azure Blob. So the repo is in this, so I can share it also later. So the expected results that I wanted to have for this project or mini example is that I will be getting an SMS, both on my iPhone and my mobile phone, and my clock, a phone call, and also an email. So let me just try to switch maybe. Let's see. Show some code. I hope you see. Can you see my screen? I hope so.
Yeah.
Yeah. Okay. Let's see. So here I have my Visual Studio. I called it durable storage functions. So a simple example. So what I did is I organized my functions into folders. So I have the orchestrator, client functions, activity functions. So my starting point of my orchestration is this. So I have a blob trigger called blob trigger start. And this is in .NET Core 3.1. And what I do is I have a blob trigger that has the name of my container. and my storage connection string that I save here in my local host in some secrets. I don't have Azure Key Vault yet, since this is just a demo one. And in here, I check if it's not empty. And what I do is that I use the method starter. In line 39, I use a starter, start new async, and call the name of my orchestrator, which is called Azure Storage Orchestrator. So if I go to this orchestrator, what I see here is I have the context. So that's all the instance and everything are saved through this context. So what I do is I save the input, what I receive from the context, as a cloud blob item, which is actually a model or an object that I created myself with different properties, because what I want later on is I want to save that in a database or Cosmos DB database and process it later in another front-end app later on. So that's what I have. And in my orchestrator, here you see the chain of workflows. So the first chain is to send a message to service bus queue, and that is that this is that function. And then the second chain is that this one, send an SMS called Twilio, that one. So I have my logic here. And then the next one, when I'm done, I also want to send an email, and I have SendGrid in here. And I wanted also to do some conversion of the image, because the image that I have locally, they're like compressed big files. So I'm working on it and just experimenting to try to integrate everything in here. So I'm gonna try to start this one without showing details in the code. You can just check the repo. So I'll start this one locally. Let's see, that one. I have a small screen. So the function app is started, and it's running, and I have an image here. Wait, this is so there. And what I want also is that one. Okay, this one. So I have my Azure Storage Explorer here, where it's connected to the durable functions storage within my app. So what I want is that I want to upload one of these images that I have locally to, for example, which one is a good one? This one. So when I upload it, it should be kicking the orchestration, unless here it's transferring. So here you see that it's starting to log, and I am actually getting a call right now from my Twilio, but I won't answer it because I'm busy. So so that's how it does. So it's running right now locally, and as you can see on, let's see if I can zoom it, on the log. So we have the time stamped here. So what it's trying is executing the blob trigger, executing the orchestrator, and it's sending a message to the service bus queue, and it sends an email, an SMS as well. And if I check my email right now, this is my work email, I actually got a message with the link to that blob that I can access through a web browser. It was a big file. I wanted to send it as like MMS, but I have to compress this one first. Otherwise, it will be too big. But that's my demo. And if we go to, like, for example, let's see, if we go to my project, because it's deployed in Azure. So here is the app. I have I have application insights as well, and just setting up the key vault for now. And I have a storage and also a service bus namespace. And in my namespace, I have a service bus queue. And earlier, I only had one message, but if I go to the service bus explorer and do, I have several because I've tried many times. Okay, if I do a pick, for example, so I'm gonna pick the one that I recently sent, and I believe this one. So here was the queue message that I also received, and it stays there in my queue until I process it later on. I plan to like create another, maybe as Azure Static Web Apps to process those images and show it as a gallery. But I need to compress it first to save some memory. So that's my demo, but I want to show you how it looks actually in the function app. So in the function app, you have a lot of options here. So you can set up your security, your configuration. So for example, app insights and custom domains. And for example, for the deployment center in a function app, you can set up here your GitHub actions. So connect it to your GitHub repository to set up the pipelines for deploy, continuous integration and development. So you can set up GitHub, and then you can select your repo here. I have my name, and then I can choose what repo I want to connect it to. So that's my demo app, and let me just finish the presentation so I can answer some questions. So let's see, and let's switch. Okay, let's see. So I'm on this part now. So I want to share also about this use case. Aside from my project, I'm also involved with this new open source project by Microsoft. It's called Cloud Katana, that was created by Roberto Rodriguez. So what I'm involved in a way that I was like advising and helping him out with durable functions. It's Cloud Katana is an open source project that helps in researching attack and defense in Azure. So it's free and open source to everyone. So if you want to know the details and how you can try it out, you can check out the links of Cloud Katana on GitHub. And I believe Roberto is also looking for developers that are interested in learning this technology and about security in the cloud. So if you want to contribute, it's open for contributions as well. And I want to share also about problem solving Azure core tools. I actually got this morning before the presentation. I got a new computer for work, and I was pulling or cloning my repo for this demo in my new computer. And what I did is I installed the latest version of Azure Core Tools, but I got this error. It's called debug executable error, and I wasn't sure what's wrong. So I did restart my Visual Studio and tried to create a new repo for my project. It didn't work. But later on, I realized after Googling that the problem is that the latest core tools, which is a 3.28.0, has this like a folder map or folder called CLI. But if you're in a Windows with 64-bit, you actually need to rename this folder with _ x64 in order to make your functions work. So I want to share this with you because it took time for me to figure it out, but you might encounter this problem. I want to share it with you. And if you want to learn more about durable functions or Azure functions, there are a lot of great resources in Microsoft Learn. And I recommend Azure Functions the University by Mark Duker. So he has a great playlist there. And Azure Serverless Community Library, serverlesslibrary.net has a lot of great examples of projects of serverless. And next one is that I want to invite you to also join us in my meetup group, Azure User Group Sweden. And we also welcome speakers, like regardless if you're new or expert speaker, you're open to share your knowledge about Azure. And this coming Saturday, we're gonna have an event about Azure Front Door. It's about breaking up monolithic websites with Azure. So it's a meetup. You can join us. And finally, I want to thank you so much for listening to me. I hope I'm not over time. And tack så mycket, we call it in Swedish. Yeah. I hope you learned something.
Yeah, it was really interesting session and very, yeah, very useful. Even in my own experience, I was working with Azure Functions, and actually I was not aware about the durable functions, but this was something I was looking for, like a complete orchestration workflow, how to handle it. It's really interesting.
Yes.
Yeah, to know
Yes.
everyone. We have learned something new today. Hey guys, if
Yeah.
you have any questions, you can ask. Or there's
Yeah.
an question. How many, with the orchestrator, how many concurrent activity we can handle? Is there any limitations for activity? Means like when you are creating sub orchestrator or the multiple activities by, the sub orchestrator. So is there any limitations with those requests or activity?
As far as I know, there's no limitations to how many activities you can create. The only tricky part is that you need to be aware about the pricing model that you have. Just like just like what I mentioned on the constraints, the do's and don't when you design your workflows. No infinite loops, because if you create infinite loops that cause a lot of sub orchestration, can you imagine how much bill you will get in Azure? Yes. Yeah. So there are a lot. Yeah, that's a lot. There's a lot of things to consider. I mean, it's no problem if we're just like doing hands-on in our local project, but if we're doing durable functions with our customers, our clients in our company, then we need to think extra and check on the proper way. Yes.
Yeah, I think we need to be very careful in terms of designing or orchestrating any functions, because it's going to cost a lot of bill.
Yes, that's right. But there's like the good side and both. I mean, the positive and the negative. The serverless is like really gives us productivity as developers, but at the same time, just like everything else, we need to think before we do something sometimes. Yes. Yeah. And I think if you need a copy of the repo and the links, I can send it later on if it's okay. I can upload it somewhere and share.
Sure, that will be helpful for everyone.
Yes.
Yeah, because that was a really interesting session. Means like I will surely I will try. Means like after the session how to create the durable functions, at least because I was working with Cosmos DB Blob Trigger with Azure Functions, and I really find very useful. But I was thinking like, yeah, it's something like just a standalone. You can just create the APIs and can use this. But it would be good, really good, if there is some mechanisms to orchestrate, because there'll be microservices and n number of services maybe you can't handle. So there should be something to handle those requests or orchestrate those functions. Yeah. So I think then you answered me today.
Yeah. I can share my repo, and then anybody who wants to contact me, you're welcome. This is my contact info, so you can connect with me on LinkedIn if you need help with anything, or if you want to talk to my user group, you're also welcome. So it's like we are a community, so we
Sure,
can
sure.
learn from
I
each
think,
other.
maybe,
Yes,
maybe we can host you when you are in Singapore, maybe next time. I think the
yes.
wonderful airport, along with the wonderful locations in Microsoft as well. I think it was
Yeah, that's
perfect.
right. I really want to go back there someday. So if I want to travel to Philippines again to visit my family, I want to go through Singapore airport. I know that you built, what do you call that? You're building an airport with a waterfall or something. Is that
Yeah,
already built?
it's there.
Yeah.
Actually,
Great.
me and my colleague Nilesh, we were in the Philippines last year for actually that
Mm,
was our last visit for Microsoft Philippines. We did presentation there, and it was really awesome. Yeah,
yes.
we hope
That's really
someday.
great. Yeah, I hope the audience, the rest of the audience have learned something. Any questions so far? Otherwise, I'll just share